In this video, we want to do a question about continuity of a function over an interval. This is a little tricky and challenging question. Show that the function f of x is continuous on negative infinity to infinity, and the function is defined in this form. F of x is x2 sine of pi over x if x is not 0. So we use this equation, this rule, whenever x is not 0. This is only for values of x that x is not 0. And if x is 0, then the function f of x is 0. And we want to show that this function is continuous from negative infinity to infinity. As you can see here, this function f of x has two rules. We have a rule for values of x that is not 0, and we have another rule if x is 0. So we have a piecewise function, and the rule of the function is changed at point 0. So one of the points that possibly this function is not continuous at that point would be probably 0. But of course we have to check that point. But for points other than 0, we have this rule. If x is not 0, we use this rule. But attention, x2 sine of pi over x is always continuous at every point except 0. Because attention, in this expression we have x to the 2, which is a polynomial. We have a trigonometric function which is sine, and sine is continuous everywhere. And here we have a rational expression which is continuous except the points that makes the denominator 0. But we exclude 0 here, so this function here is continuous everywhere except 0. So for every point other than 0, we know that f of x is continuous. So let me write down this here. x2 sine of pi over x is continuous for x in the region from negative infinity to 0 and from 0 to infinity. Again, the reason for this is that x2 is continuous everywhere. Sine is a trigonometry function that is continuous everywhere, and pi over x is continuous except at 0, but we have excluded 0 here. So the only point that we have to check for the continuity of the function is 0. Now we have to check the continuity of this function at 0. Remember the 3-step definition of continuity. A function is continuous at a point if, first of all, at that point it is defined. And as you can see, when x is 0, the function is 0. So f of 0 exists and it equals 0. So the function f has the first condition for continuity. It is defined at 0. Now we have to find limit of the function f of x. We have to find limit of f of x when x approaches 0. And for finding limit of this function, which of these two rules we have to use for finding the limit when x approaches 0? We have to use this rule, x2 sine of pi over x. Let me explain to you why we have to find the limit of this function from that rule. So for finding limit of f of x when x approaches 0, we have to find limit of x2 sine of pi over x. But what is the reason that we have to use this rule for finding limit when x approaches 0? Because attention, when x approaches 0, x is not 0. X is approaching 0. X is a number close to 0. And when x is not 0 but close to 0 or any other point other than 0, we have this rule. This rule is only for x when x is 0. So of course, for finding limit, we have to use this rule for finding limit of this function. But the thing that makes this question a little tricky is that finding this limit is not straightforward. Basically, you cannot find this limit with direct substitution. And the reason is here. Basically at here. When x approaches 0, pi is a number over x which x approaches 0. Pi over x, or a number over x which x approaches 0. This goes to infinity. Remember, when we have a number over 0, over something that approaches 0, this goes toward infinity. And sign of infinity does not exist. So by direct substitution, we cannot find this limit. So what method then we have to use for finding this limit? We have to use a squeeze or sandwich theorem. And the reason that we guess that we have to use a squeeze or sandwich theorem is exactly this part. If you remember, whenever we have a sine or cosine with an expression in the form of pi over x or 1 over x or 2 over x or something that goes to infinity when x approaches 0, for these type of questions we use squeeze or sandwich theorem. Attention, if instead of this we had something like sine of x and x approaches 0, so of course for this just substitute 0 and then sine of 0 is 0. You don't need to use a squeeze or sandwich theorem. But here, because x is in the denominator and x approaches 0, we have to use a squeeze or sandwich theorem for finding this limit. So to find this limit, we use a squeeze or sandwich theorem. If you remember, for using sandwich or a squeeze theorem, we start from sine or cosine, depending to the question. And always we know that sine or cosine are always between -1 and 1. It doesn't matter what is the angle here. Sine and cosine are always functions that are bounded and their maximum is 1, their minimum is -1, so they lie between these two numbers. After this, the thing that we have to do is to try to make this expression in the middle in the form of the expression that you want to find its limit. By comparing sine of pi over x with this expression, we notice that we need x to the 2 to be multiplied by this. So, for this reason, we multiply left side, the middle term, and the right side of this inequality by x to the 2. And because x to the 2 is always positive or greater than equal 0, the direction of this inequality doesn't change, and simply we can multiply this inequality by x to the 2. By multiplying by x to the 2, we have negative x to the 2 in the left side. In the middle, we have x2 sine of pi over x. And in the right side, we have x to the 2. Now look at this. Instead of finding limit of this expression, which is very complicated, we can simply find limit of the left function, limit of the right function. And if these two limits are equal to each other, then the limit of the middle function is equal to that number. So now we have to find limit of negative x to the 2 when x approaches 0. This limit is 0. And we have to find limit of x to the 2 when x approaches 0. This limit is also 0. Plug in 0, the limit is 0. Now from a squeeze theorem, we can conclude that limit of the middle function, which is x2 sine of pi over x when x approaches 0, is also 0. Because limit of the left function and limit of the right function are 0. So the limit of the middle function, which is trapped between these two functions, is also 0. Now look at this. Here we know that f of 0 is 0. And now we know that the limit of the function when x approaches 0 is also 0. So this function is continuous. This was the first condition for continuity. This is the second condition, that the limit should exist, and it exists and it equals 0. Let me erase this from here. The limit exists and now we know that it equals 0. The third condition for continuity is that limit of the function when x approaches 0 should be equal to f of 0. But now we know that it is equal to each other because the limit is 0. F of 0 is also 0. So these are equal. So from this we conclude that f is continuous at 0. Remember that here we know that f is continuous for negative infinity to 0, from 0 to infinity, and now we have proved that it is also continuous at 0. So what we conclude from all of this? From all of this we can conclude that f is continuous over negative infinity to infinity, which means that it is basically continuous everywhere. This was a little challenging question, but I hope you enjoyed this video. If you liked this video, please subscribe to my channel and see you in the next videos.